Okay.
Now it has started.
Yes, recording has started. Good morning, all of you. So we have discussed the unsymmetrical faults and symmetrical components in the last three classes. Okay, actually 3 days. That means last 6 classes. Today we'll start the uh, circuit breaker. Okay, because I have in my part circuit breaker and unsymmetrical faults. Okay, so the first part is over. So let me share my screen. Is my screen visible?
Yes, ma'am.
Okay. Now circuit breaker, you have heard the name circuit breaker. Also, you had some knowledge about circuit breaker. How is it? It is different from the fuses. That you have the preliminary knowledge you gained in second year, second semester, in power supply systems. So the functions of a circuit breaker is same as that of the fuse. Is to open and is to close and open the circuit. Okay. In closed position, normal load current flows through the contacts just as it flows through the fuse. In open position, voltage of the source appears across the contacts. So the circuit breaker is designed in such a way so that it can carry the rated current continuously. There should be no overheating or any problem. And then it should withstand the rated voltage permanently. Okay, if the circuit breaker contacts are open, it should be able to withstand the rated voltage. Now comparison of circuit breaker and fuse, you can easily understand that fuse should be replaced every time, okay, after operation, but circuit breaker can be reset in less time. Okay, there is no such replacement required in circuit breakers. Fuses are used to isolate the faulty circuit. Purpose is same, but for low voltage fuses are used. For high voltage, especially above 3.3 kV, the separation is done by the circuit breakers. Okay, circuit breakers are preferred where continuity of service is important. First point will be circuit breakers where fuses cannot be used. Why fuses cannot be used? For high voltage circuits, if fuses are used, there may be flashover. Okay, so in circuit breaker, there is some special mechanism for mitigating that flashover, or we call that for extinction of the arc, that we called arc. Okay, and another, circuit breakers are preferred where continuity of service is important, because frequent fuse replacement is difficult. Okay, so every time fuse needs to be replaced, so it may be hazardous, it may not be possible also sometimes. Okay, now circuit breaker should be robust to withstand the stress due to large fault current. It must not suffer any damage due to closed dead short circuit. It must not suffer any damage because the fault current, when there is fault, the circuit breaker contacts are separated. Okay, so that there is interruption of current. But what happens? That for very short period of time, till the breakers are separated, the contacts are separated, there the huge fault currents may flow through it. Okay, so it must not suffer any damage due to the flow of that current. Must be absolutely reliable for fault clearance. Okay, because it is used for clearing of fault. Though it cannot sense fault, fault is sensed by the relay coil and it sends the signal to the circuit breaker. The maintenance requirement should be low. Now circuit breakers are used in all important switching locations of high. Hello? Any
Yes,
problem?
ma'am. No, ma'am.
Can you hear me properly?
Yes, ma'am.
Okay. So in all important switching locations, high voltage electrical systems in generating stations, connecting transformers, transmission lines, and heavy engineering industry. Okay, to disconnect individual large consuming apparatus. So circuit breakers are used everywhere. Now, besides circuit breakers are always accompanied by isolators or load break switches. Okay, the isolators are load break switches. Why these are used? See, it is not sufficient to merely break the current for high voltage systems. Okay, the circuit must be interrupted at a second place to allow maintenance work or inspection, because from outside you cannot be sure that whether the circuit breaker is off or it is on. It must be for high voltage circuits. In order to perform the maintenance or inspection work, it must be interrupted at a second place, okay, for safety purpose. And also that visually it should be clear that the circuit is in off condition. Okay, it is under no load condition, then only maintenance work can be done. So see, this is the circuit breaker, this is the isolator. Isolators are nothing load break switches we have used in machine lab, or in power system labs also. I don't yes, in power system lab I don't know, but in machine lab we have used the isolators. These are manually operated switches. Okay. So why this circuit? You can understand that isolators are just switches, load break switches. They do not have any sophisticated mechanism. Okay. But circuit breakers, they have the mechanism to extinguish the arc, because whenever you are breaking a huge current, then what will happen? That energy will be transformed into electrostatic energy and huge voltage will be developed. Okay, so the medium between the contacts, see this medium between the contacts, due to the high voltage gradient, it may be conducting. So that arc will be established between the contacts and it should be extinguished. So load break switches do not have that property, so they cannot be operated under loaded condition. Okay, under unload condition it cannot be operated. It cannot be closed also, cannot be opened also, but that can be done by this is the isolator. It cannot be closed or opened under loaded condition. It should always be operated under no load condition, but the circuit breakers are operated under loaded condition. Okay, now see, instead of using two circuit breakers, it is always advantageous to use one circuit breaker and this one, two isolators. Okay, so as I told you that the isolators are always operated under offload condition. So what will happen? Suppose you need to do some maintenance work. So if you need to do maintenance work, say in this feeder, okay, then what will happen here? If both are circuit breakers, you have to, if you have to see, say you have to do one maintenance work, then this should be open. Okay, and instead of using two circuit breakers, if I use this one, then just by opening the circuit breaker, then by opening this switch, the maintenance work can be done, and in the meantime by closing this one, the power supply can be in this way. Okay, so isolator, suppose we want to there is a fault, we need to clear the fault. What will happen? First the circuit breaker will be operated, and after that the manually the isolator should be operated. So if any maintenance work needs to be done, it is clearly visible the isolators are open, that means it is under offload condition. While switching on the circuit or restoration of power, what should be done? first the isolators should be closed, isn't it? From common sense you can understand. First the isolators will be closed because it is operated under offload condition. Then what will happen? Yes, first the isolators will be closed and then the circuit breaker will be closed. Okay. So, uh, in this way, the circuit breakers and isolators are operated. Now, there is some interlocking mechanism, okay, for the isolators. What is the interlocking mechanism? Because under offload condition, first the isolators can be switched on, then the circuit breakers. But when it is under loaded condition, you cannot operate the isolators. Okay, under loaded condition, there is some interlocking mechanism so that by accident someone does not open this isolator. Okay, first this will be open, then you can open this one. So interlocking mechanism is there. Sometimes isolators, they are used on both sides of the circuit breakers. And what I have told here, they are written. You go through them. Now the switching device which affects the disconnection must comply to two main conditions that I have already. First condition I have already told, the disconnection must be visible. Okay, because for circuit breaker, that whether it is operating on under no load condition, it is not visually, it is not visible. Now, second point, at the occurrence of an overvoltage, a flashover to earth must take place and not a flashover to the opposite contact. Okay, so in order that the flashover does not take place to the opposite contact, the isolators are used. Now, technical difficulties arise if the circuit breaker designed for breaking large currents are expected to fulfill both this condition. Actually, to fulfill both the conditions, the isolators and the circuit breakers are used. First condition is fulfilled by the isolators. Okay. So, it is advantageous to divide the breaking and disconnecting functions into two devices, one circuit breaker, another is that isolator. Now, load break switches or isolators are used to make and break the normal current is less burden than the circuit breaker. Break only normal currents because they does not have any function during fault. Okay, the function is performed by the circuit breaker. Designed as a manually controlled device, conforming, of course, to the safety regulations. Not equipped with an automated mechanism. It is simply manually operated. Now, what I told you, isolator is open and closed only when the circuit is already dead. They cannot be employed for making and breaking fault currents, but they must be capable of carrying fault currents. Okay, because unless the circuit breakers operate, though we say that circuit in the occurrence of fault, circuit breakers must operate instantaneously, but still there is some time lag. So, till that time, the isolators should be able to carry that fault current. And what are making and breaking of fault currents? See, making of fault currents is the current. You know, you have studied the fault current, fault operation in alternators. You have seen that first 1 or 2 cycles, the current is huge. Okay, and then ultimately it gradually decreases and goes to the steady state value. So the first loop, the first peak of the current loop is the making current. Okay, that will discuss making current, breaking current, that will discuss while studying the rating. But that is making current is important because it is the maximum value of the first loop. Okay, so it must be capable. They cannot be employed for making and breaking of fault currents, but they must be capable of carrying the fault currents. So that making breaking fault currents that should be taken care by the circuit breakers. So isolators are often connected to each side of the circuit breaker. Now the circuit breaker switching operation is characterized by the voltage and current immediately after and immediately before the action. At the instant of contact loss, the rated voltage followed by the making current At the instant of contact separation, the breaking current followed by the recovery voltage. Recovery voltage is the voltage appearing across the circuit breaker contacts after current interruption. Okay, we'll study them in details later on. So it is the recovery voltage is the voltage across the circuit breaker contacts when it is the contacts are separated. You know, circuit breaker basically has two contacts. One is fixed contact, another is moving contact. And during fault, what happens when it gets the signal from the relay? The moving contact separates from the fixed contact. Now, so the these things we have we just go through them. The cost of a circuit breaker is influenced by rated current, rated voltage, fault current, or MVA, isn't it? Because circuit breaker is rated at by the values of the voltage and current at which it will operate under normal condition. Also, the fault current or MVA is given. That means how much fault current it can withstand. Now, current carrying part of the circuit breaker consists of moving and fixed contacts, as I told you. When the breaker is in closed position, sufficient pressure is exerted on the contact surface. Okay, so that it remains in contact. Okay, it does, under normal condition, it should not get separated. To prevent the contact resistance from reducing the flow of current through the circuit. Okay, it should remain in close contact. It should be sufficient pressure is exerted so that there is no loose connection. During circuit breaking, the contacts separate at an appropriate speed. Okay, it cannot be that it is not possible the contacts are separated at high speed. There should be some optimization because there are both problems in high speed separation. Also, there is problem or also there are advantages. We need to make the uh, we it is it will be advantageous if the circuit breakers the moving contact separates from the fixed contact at a high speed, very high speed, then only the current will be interrupted. But at the same time, if it gains speed more than the safe value, then what may happen, that voltage gradient would be very high, that may be dangerous. Okay, that voltage gradient that you will understand uh, just after some slides, because voltage gradient is the deciding factor, or it is the factor due to which that arc develops. Okay, now contact wipe is, and what is contactor, we go through the figure, it will be clear. See, this is the contactor, because this is the shaded portion is the fixed contact and this is the moving contact. So when there is fault, moving contact separates out from the fixed contact. It's not like that moving contact will be connected at the end. Then it may be dangerous because then any moment this may get open. Okay, so it is kept like that. A sufficient portion is always in contact under high pressure, or pressure is exerted by some mechanism. It may be spring mechanism or any other mechanism, and this portion, common portion, is called contact wipe. Okay, so there is wear and tear in this portion. Now, with each making and breaking operation, burning and shortening of the contacts take place. The moving parts require some time to reach the nominal opening speed during the period of contact wipe. Thus, the chance of low contact separation speed and consequent contact welding can be avoided. Now, this is how after separation, this is during operation and it will take some time to separate, and after separation it will be like this, and in this portion the arc will be developed. Now you must have heard the name autoreclosing. Okay. Now is it clear, students?
Yes, ma'am.
Yes, ma'am.
Okay. You have heard the term autoreclosing. Okay, what is autoreclosing? Suppose a branch of a tree is falling on the lines and two lines get short circuited. What will happen? Momentarily it will sense fall. But what happens? Within a very short time that branch will fall to the ground. Okay. So the fault will be cleared. But if there is no auto reclosing mechanism in the circuit breaker, even after the fault is cleared, it will be kept open. Okay, so this is not desired. So auto reclosing property is there. As soon as the auto reclosing property is to is there for these faults of very short duration, and also as soon as the arc is extinguished and the path is sufficiently deionized. Why it is called deionized? Because I told you that if it is so simple, it were so simple that contacts are after the contacts are opened, all the current is zero. But it is not so simple. When the contacts are open due to high voltage gradient, or there is very high temperature also, some ions and electrons will be there. So the path is full of ions. Okay, so an arc will be there. Clear? So after the arc is completely extinguished, then only the circuit breaker should be reclosed. Okay, so as soon as the arc extinguishes the fault and the its path is sufficiently deionized to prevent the reoccurrence of a breakdown, the network cannot be reconnected. Okay, for no stresses of the arc remain, till no stresses of the arc is there, there will be no recloser. If these processes are carried out quickly enough, the system can be maintained in operation. Also, you know of the critical clearing angle. You have studied in power system stability. You know that if the reclosing time is more, then there may be chance of losing of stability. So the circuit should be reclosed within a very short time. Okay, so both are important. Okay, it is very necessary to extinguish the arc very quickly, and the recloser must not be earlier than the full extinction of the arc, and the recloser should not be later than the critical clearing time. Okay, so two conditions of successful recloser are: the reclosing time must be longer than the time required for deionization. After complete deionization, reclosing will be done. The reclosing time must be short enough so as not to affect the stability of the system. It must be reclosing time must be smaller than the critical clearing time. Now, factors affecting deionization time are magnitude of short circuit current. You can understand if the short circuit current is lower, then the deionization time will be lower. The magnitude of voltage, climatic condition, length of insulator, all these things. Okay. Now, this is an example. Now, in power system stability, you have studied these types of systems, isn't it? Now, I'll show you three conditions. See, we have considered a double circuit line and we have considered that there is a fault here. Now, before fault, this is the equation P equal to P max 1 sine delta pre-fault. During fault, what will happen? It is P max 2 sine delta, because power in this receiving end will be least, because most of the power, it is the fault current. Okay. So it will be have the least value. Then after post fault condition means after the fault is cleared, if the system is not restored, the fault is cleared means this is open. Okay. So there is only one line. So obviously, if the fault is cleared, the power will be increased, but it will be less than when the both lines were operating. So P1 greater than P3 greater than P2. Now you know, see, this is the figure. You see, this is the power angle curve. This is delta. This is P. So what will happen before fault condition? This is the curve. Okay, the larger one. Then when the fault has occurred here, okay, say when the fault has occurred in this position, so what will happen? It will decrease. So this is the during fault curve. Okay, so this is the during fault curve. Is this the time to join? Anyway, this is a during fault curve, and let the if the as the fault has occurred at this point, it will come to this point. Okay, it will go, and when the curve was at this position, then what happened? This is the instant of breaker operation. That means the fault has been cleared. Okay, that means the second line that is disconnected. So as soon as the fault is cleared, the curve will again increase to this point. The power will increase to this point. So it will follow this curve. Okay. So when at this point the fault is cleared and the breaker recloses, so the both the lines are again in operation. So it will ultimately, the point will shift to the original curve. Okay. Again, I am repeating the fault. It is operating. The system was operating along this curve. The fault has occurred here. So the system will now operate along this curve. When it was in this position, when the power was this position, then what happens? The fault is cleared. Okay, so it will increase. The curve will be like this. Fault is cleared, but the second line is not restored. Now the breaker in the second line recloses. That means the system will be has been restored at this point, so it will increase like this. So this is we call the decelerating area. This we call the accelerating area. So if the fault clearance is before the critical clearing time, decelerating area will be more than the accelerating area. It will be more than A1 and the system will be restored. Okay. Then this curve system without auto-reclosing, that means in the previous one, the gasket breaker has auto-reclosing function. Therefore, after the fault is cleared, it is automatically reclosing and it is shifted here. But if there is no auto-reclosing function or feature, then what will happen? Even after the removal of the fault or the instant of breaker operation, even after the breaker is closed, it will not get shifted. It will operate in this position only. Okay. It is the instant of breaker operation, but breaker, there is no auto-reclosing property. That means breaker has not been closed. It has a breaker operation here means the fault is cleared, the contacts are open. Okay, but there is no auto-reclosing feature. The contacts are not closed, so you cannot shift to this position. It will continue moving in this position because only one line operation will be there. So what will happen? It may be possible that this decelerating area is less than the accelerating area. So if there is no auto-reclosing function, then it may be dangerous. Okay. Now, this one, system with auto-reclosing feature of circuit breaker and fault sustains even after the auto-recloser. This is the most dangerous portion. See, when there is auto-reclosing function, it is very, A2 is generally, it is very obvious or not obvious, it is very likely that A2 should be less than, it should be more than A1, which is desirable. Here, it may be possible A2 is greater than A1, but very little chance. But here, what happens? If the recloser is there, even if recloser occurs after, even when the fault persists, then what will happen? See, here the fault has occurred, then it has moved here, and then it is moved. It cannot be operated in this line. Okay, so what will be there? There will be no decelerating portion here because it is not operated in this line. Okay, so there is only accelerating portion. Clear? So what happens? This is the most dangerous part. So auto-recloser must be there for after the clearance of the fault. So it may be concluded that auto-reclosing feature is helpful only when fault is cleared within auto-reclosing time. System will return to its original operating status. If fault sustains after auto-reclosing, the system condition will be worst. System may survive without auto-reclosing also if the decelerating area is higher or equal to the accelerating area. Okay, you please go through that chapter, power system stability, you will be able to understand. Now, multi-shot auto-reclosing. So, fast recloser at the instant of fault, 80% of the fault is cleared. Okay, fault occurs momentarily. Now, so fast recloser at the instant of fault, 80% of the faults are cleared. So most of the system operates after first recloser only. Second recloser will be after 15 to 45 milliseconds from fault. Okay, about 10% of the remaining faults are cleared. Third recloser, see what happens. First recloser, if it senses that fault is not clear, it will open. Then it will go for second recloser. It will go for third recloser, and fourth recloser can be made by hand. If this recloser fails, there is a clear indication of permanent fault. Okay, and the system should be shut down, and that fault should be cleared. Now, opening and closing operations. That opening and closing operations, that will be different for different circuit breakers. You have heard the name oil circuit breaker, OCB, minimum oil circuit breaker, MOCB, SF6 sulfur hexafluoride circuit breaker, vacuum circuit breaker, air circuit breaker, ACB, or air blast circuit breaker, ABCB, etc. Okay, so according to the type of, actually the name is given on the basis of the type of arc quenching medium used. See, in SF6 circuit breaker, SF6 is used to quench the arc. In all circuit breaker, oil is used. In air circuit breaker, air is used. Okay, in air blast circuit breaker, compressed air is used, like that. So that mechanism, opening and closing mechanism will be dependent, can be different for different circuit breakers. The opening of circuit breaker, forces due to contact, friction, inertia of movable parts, opposing force due to quenching medium. Okay, so opening force must overcome these forces. Okay, because I told you forces due to contact, the contacts are kept under pressure so that they should not get separated under normal condition. Frictional force should overcome the frictional force, and there must be some inertia of the movable parts and all these things. So operating mechanism should overcome these forces and achieve the desired speed. So you can understand, if it is required to overcome these forces, some speed will be there. It cannot be done instantaneously. Now this is the figure, simple figure. See, this is the fixed contact. This is the moving contact. This portion is the contact Y, common portion. Okay, this is the sliding contact. This is the trip coil of the circuit breaker, and there is the mechanism for opening and closing. That we will understand when we'll take the consider different circuit breakers. Now opening time interval from trip coil energization to the instant of contact separation. See, the trip coil energization means trip coil of that circuit breaker. That means the relay will sense the signal when it is sending the signal to the trip coil of the circuit breaker. Then from that time the time is counted to the instant of contact separation. There will be some time required for to separate the contact. So as soon as the contact is separated, that time is considered. That is called the opening time. But it is not like that. The contacts are separated, so everything is normal now. Now the contacts can, after clearing fault, contacts can be again the contacts can be made. It is not like that, because then as soon as the contact separates, then there will be arc formation. So that time, before arc formation, if the contacts again close, then you have seen the time before fault clearance, if there is autorecloser, it is very dangerous. So there is some time to extinguish the arc. That is called arcing time. Time interval from contact separation, because after contact separation only that arc will come into the picture. So to arc extinction. So what is the total breaking time? Total breaking time is the time difference from the instant of the trip coil energization to the full extinction of arc. Okay, that is the total breaking time of a circuit breaker. Now opening speed to limit contact erosion, to control the fault duration, to control the lightning pulses waves that may appear across the contact. Okay, so some optimization should optimized speed will be the contact should operate at some optimized speed. Now, why this contact erosion is coming and fault duration, the time starting from arc interruption to recovery of normal dielectric strength of arc quenching medium. Now, opening speed of some typical opening speed of circuit breaker and SF sheets are given here. Closing operation, opposing forces are there. Electromagnetic forces between the contacts, action of operating spring. Okay, spring must be there so that when it is uh, opened, it should be kept in open position. Inertia of the movable assembly, opposing force due to the quenching medium, and always the friction. So closing should not be fast to reduce the pre-arcing time and the damage due to contact due to that. And contacts are subjected to making current. That I already told you what is making current. Now closing speed to reduce the pre-arcing time to a minimum, to decrease the magnitude of current at the instant of contact engagement, to reduce contact erosion. If the speed is very high, there may be more contact erosion, to reduce the energy requirement for closing mechanism. Okay, if it is required that very fast that it should be closed, then the energy requirement should be more. Now, work done by the mechanism against electromagnetic repulsion is this one, I square V dt. Now, arc phenomena. Why the arc is generated, that you need to know. What is the reason for development of this arc? Now, electric arc has the appearance of a brightly burning electric discharge concentrated into a thin volume. Okay, so it is not that it will spread over a large area. It is concentrated into a thick column. Now, what happens at the instant of contact separation? At the instant of contact separation, the temperature at the points of contact and their surroundings rise. Okay, the temperature reaches to a very high value. Okay, that we'll see. And the matter vaporizes. The area and pressure between the parting contacts decreases rapidly and increase in electrical resistance. Okay, because there is no longer they are in contact. Initially it was short circuited, so now the electrical resistance will increase. Concentration of current at few contact points at an increase in the current density at these points 10 to the power 6 to 10 to the power 7 ampere per square meter centimeter. It is very high. High current density associated with high contact resistance. It is the result. It causes intense local heating, resulting in thermoionic emission. There will be emission of electrons and ions, and that is the resultant of the very high temperature. So it is called thermionic emission. Now this is the equation. The electron current due to thermionic emission are this one. I equal to 80 square e to the power minus bt. So B is a constant depending upon the type of the material used in the contact material of the circuit breaker. Okay. So this is about thermionic emission. Now, field emission. There is another type of emission that is called field emission. What is that field emission? At the instant of contact separation, voltage appearing across the contacts causes a large voltage gradient in the microscopic gap between the contacts. You see, when the contacts are separated means it is not like that visually it can be seen. It because it is microscopic gap, so you can understand microscopic gap is very less. And what is the voltage gradient? The electric stress due to voltage gradient is voltage per unit length. And you can understand that voltage gradient will be very high if the length of contact separation is less. Now, at the instant of contact separation, voltage gradient is very high. Now, as the moving contact it separates from the fixed contact, that length length of that gap increases, and gradually the voltage gradient it decreases. But at the instant of contact separation, voltage gradient is very high. This large electric stress due to high voltage gradient is capable of ionizing the gases in this space or of tearing away electrons from the contact surfaces. Okay, this electric stress becomes very high as soon as the contacts have separated. Okay, maybe the separation is microscopic length, but the lower the separation, the higher will be the voltage gradient. Okay, so the electron current due to field emission, this is the equation, the current for the field emission. Okay, so you can see how the current is carried out even after the contact separation, because the ions and electrons, they are created in that gap. It may be noted that both the currents may be increased by lowering the work function. So as it is dependent upon the work function, by changing the material or the employment of an oxide layer or irregularities at the cathode surface, those currents can be increased. Now, see, if we consider especially copper contacts, it has been seen the thermionic emission is negligible. Okay, and only the field emission is there. This is true for many other materials. Okay, and almost in all cases of circuit breakers, it has been observed that field emission appears to be solely responsible for initiation of arc at the contact separation. So thermionic emission is also a cause, but it is not a major cause for initiation of or creation of this arc. Field emission is the real cause. Okay, but thereafter become ineffective as the separation between the contacts increases, because I told you voltage gradient remains maximum when the contact separation is minimum. So after the contacts have separated by a fixed value, that it cannot be the thermionic emission no longer takes place, because the voltage gradient is not sufficient. Because you know voltage, what happens in air, what is the breakdown strength of air, 30 kb per centimeter. So it depends upon per centimeter. So suppose you apply 30 kb in air between two conductors and you increase the length beyond 1 centimeter, then there will be no flashover or no corona discharge, anything. But when the separation is made below 1 centimeter, then there will be breakdown in the dielectric strength of air. Similar is the case here. Okay, the voltage gradient will appear to be a major factor when the contact separation is low. Now, and so field emission and thermionic ionic emission both are responsible for the initiation of arc, but the role of field emission is more. But after contact separation, who is responsible for the continuation of the arc? That ionization is the process that helps to maintain the arc after initiation, because after initiation means already electrons and ions will be there. Then the ionization process, the ions will collide and the electrons will collide against each other, creating more ions and electrons, and that will continue. Okay, so ionization produced by the collision of electrons accelerated within the field of parting contacts. Now there is space for the movement because the contacts have separated to a particular distance. So the collision of electrons accelerated within the field of parting contacts, it will produce the ions, and that ionization process will continue. So you need to eliminate that ionization process, okay, by introducing the arc quenching medium. Clear? Now there are two types of Can you hear me properly? Anybody is there?
Yes, ma'am, we can hear you.
Two types of electron particle collisions occur. Okay, this is the ionization process. One is non-elastic, another is elastic. Elastic, you can understand, one will transfer its momentum to the other, and that will transfer. Ultimately, all will there will be more creation of that mobile ions. Okay, first non-elastic. Non-elastic means according to the kinetic theory of gases, gas molecules are in constant active movement at normal temperature. They are constantly vibrating, The temperature is above 3000 degrees Celsius. You can understand. The molecules gain huge amount of kinetic energy at collision. Cohesion is disrupted. Okay, their bonding is disrupted, breakdown into simpler molecules and later into atoms. So complete disruption of the bonding occurs in non-elastic. The temperature is raised to 600 degrees Celsius. The collisions become so instant that electrons are torn away from the atoms or molecules. Okay, so molecules collide and break into atoms, demands a certain amount of energy for dissociation. This type of collision is called non-elastic collision. That is complete dissociation of the ions of the atoms and molecules. And it occurs at such high temperature. Now, maintenance for initial occurrence of the arc, that non-elastic collision, it occurs in this way. Now, maintenance of arc, the accelerating electrons collide with the gas atoms existing in the contact gap, push them to reach their excited states. These excited atoms undergoes atomic transition into the ground state. They liberate photons. These photons may either reach the cathode to liberate fresh electrons or impart additional energy to the other existing atoms, leading to their ionization. Thus, the ionization particles, they help to maintain the arc. Okay, this is how the ionization is maintained due to inelastic collision. Now, what about the elastic collision? The molecules do not possess sufficient kinetic energy. Okay, this is elastic collision. Dissociation of atoms or molecule does not take place. Only some free electrons are liberated. They interchange energy, keeping the total value of kinetic energy of both particles same after the collision as before. You have studied the elastic and inelastic collision. In elastic type of collision, the kinetic and total kinetic energy will remain fixed. Okay, which is not true for non-elastic collision. So one kinetic energy will transfer to the other. One particle will transfer its kinetic energy to the other. So the collision is said to be elastic. The maintenance of arc after elastic collision. The voltage gradient in the gap, it imparts considerable energy to the electrons previously liberated by the field emission. Okay, so the electrons have already been liberated due to field emission during the initiation process, starting process. So what happens? It imparts considerable energy to the electrons. Okay, the electrons are already there. Electron ions are already there in the medium, so it gains energy. The electron undergoes collision with the gas atoms or molecules, imparts kinetic energy to it, again gains energy through acceleration in the gap. So the electrons and the ions are accelerated in the gap because they are gaining the momentum. The excited atom or molecule undergoes several such elastic collisions with many other accelerating electrons. They accumulate large amount of kinetic energy, lead to thermal ionization of the gas particles. Okay, so gas particles means in the medium you have in air circuit breaker you have air in the SF6 circuit breaker you have SF6. So the thermal ionization, there will be always some gas present. Even in liquid also it will transform into gaseous form due to high temperature. So accumulate large amount of kinetic energy, It leads to thermal ionization of the gas particles. Now, these ionized particles are primarily responsible to maintain the arc after initiation. I don't know whether after arc after should not be any two after initiation. Okay, so the field emission is no longer responsible for maintaining the arc. Who is responsible? The ionization phenomena is responsible. Okay, ionization phenomena and the elastic and non-elastic collisions are responsible for maintenance of the arc. Okay.
Yes,
So
ma'am.
I think I will stop here today. So you go through some book. I will provide you this copy also. So you go through it. Unless you go through it, you won't be able to understand. Okay. Now,
Okay, ma'am.
Okay, ma'am.
okay, 27 students are there. Just 1 minute. Okay, then thank you all. I will again continue in the next class.
Thank you,
Okay,
ma'am.
you please go through
Thank you,
the,
ma'am.
Thank you, ma'am.
you please
Thank
go
you,
through
ma'am.
the class notes.
Thank you,
And
ma'am.
also to go through any book. Okay, okay. Thank you all.